to the last part of AC theory lesson 1, actually reviewing DC theory. So we already did a series circuit, we did a parallel circuit, now we're going to do a series parallel combination circuit. So just like it says, it has a couple resistors in parallel and some in series. So the first thing we need to do is find two resistors in the circuit that we can combine that won't affect the function of the circuit as we combine their resistances. So we're looking at these two resistors right here, this pair and this pair. So if I combine these two in parallel, sometimes you'll be combining resistors in series, sometimes you'll be combining resistors in parallel. But if I combine these two resistors in parallel, it's not going to affect the resistance of these two resistors or the amount of current that's flowing through this whole circuit. So what I want to do is I want to solve these two at a time here. So the first two at R1 and R2, R1 is 100 ohms and R2 is 250 ohms, and since they are in parallel with each other, then what I need to do is either do the product over the sum method or the reciprocal sum method. Now you can, that's a fielder's choice, you can do whatever you want to solve that, but I like to use the reciprocal sum method all the time because it works in every case. So I just get used to doing it on my calculator, and since I showed everybody how to do this on their calculator, if you've got a TI-30X calculator, it's a pretty simple procedure. We're going to take 100, we're going to enter it into our calculator, and I know you can't see me doing this, but maybe you could just follow along. If you've got your calculator, you're going to punch in 100. You're going to hit the x to the minus 1 key, which gives you the reciprocal. We're going to hit the plus key. We're going to hit 250. We're going to hit the x to the minus 1 key again, and then we're going to hit equals. Now that just gives us the overall total reciprocal. Now we need to hit the reciprocal key one more time and hit equals one more time, and when we do all that, it gives us 71.4, and I'm going to round that out to 0.43. It's like 0.428. We're going to round that out to 0.43, and that's ohms. Okay, so and that goes along with our rule again that the result, or the total resistance in parallel of any parallel resistors has to be smaller than the smallest resistor. Smallest resistor is 100 ohms. So and that goes along with it as we've got an answer that's less than 100 ohms. Our other pair, 3 and 4, is 350 ohms in parallel with a 200 ohm resistor. So once we do that, again on our calculator, we do 350 reciprocal plus 200 reciprocal equals, and we end up with an answer of 127.27, and it goes 272727. So we're just going to leave it at 27. Now, if you do the product over the sum method, then you should get the same answers. So that would actually give you two different ways to do this problem, and then you would end up with the same answer. So we should have, now we've got a resultant resistor here and another one here. Those two resistors are these values that we just calculated. So we've got two resistors in parallel, essentially. That's the effect of that. So now we can take those resultant resistors, which would be the resistor R1 in parallel with R2, and we can add it to, I'll put these in parentheses, so that's the sum of those added in parallel. And we can add those together with resistor R3 and R4. Excuse me, got to go back here a second and get that in parallel with R4. Okay, and when we do that, that's just a simple addition problem. We got 71.43 plus 127.27 equals, and if I add that up, on my calculator, I'm going to get, I got 198.70. So, and if I just glancing at that, looking at it, I should get, yeah, 198 and some change, and then, yeah, 47 and, or 27 and 43 comes out to be 70. So that would be my total resistance. Now, one more time, we've got voltage and we've got resistance, and we need to calculate current. So we've got I equals E over R. We're going to replace the E with the 24 volts. We're going to divide that by 198.7. We can drop the 0 off of that since it doesn't add anything to the problem. And we'll end up with 24 divided by 198.7 gives us an answer of 0.120. And I'm going to round that off to an 8 out of here, 0.1208. It's like 785 something, but we only need about 3 or 4 significant digits. So that is in amps, because all my other units are whole units. So if I want to convert that to milliamps, I would move the decimal point over 3 places to the right, and I should have 120.8 milliamps. And that would be the answer for my current. So, okay, well, that's it for review of DC theory right before we go into AC theory. So you should have a firm grip on DC theory before we start getting into AC theory, so you don't get lost. And we'll see you on the first few videos of AC theory.